All right, this video is to introduce you to confidence intervals, specifically what point estimates are and how we're going to find the margin of error and what that means. It is a lot of text and not a lot of examples, so I'm going to try to be as detailed and concise at the same time as possible. So we are getting into another part of statistics that is called inferential statistics. That's when you take sample data and you try to figure out what's going on with the population based on the sample. So what we're going to do is we're going to take a sample of size n, whatever that is, and then maybe we find like a sample mean or a sample proportion, just depending on what variable we're wanting to look at. And we're going to try to approximate the population mean or the population proportion, realizing it's probably not the exact value, but it's as close as we can get based off sample. So if you would like to estimate the population mean, you're going to use X bar to do so. And so let's just say here in this example, you want to know what is the average number of songs consumers download on iTunes. So you could do a survey, or you could even just random data from a sample. You get a mean and standard deviation. And so you're going to use that sample mean to approximate the population mean. And that's what we call that point estimate. Okay. And so that's going to be where we actually center what we think the distribution should look like. And then we're going to use the standard deviation in order to try to figure out what that is. But since we're taking samples, notice by the central limit theorem here, we're going to be looking at standard deviation over square root of n. And we'll talk about this a little bit later in another video. When you only know X bar and S, you don't know sigma, then you're going to have to use S also to approximate your sigma. And so when you're trying to find your standard deviation of your sampling distribution, you're going to approximate that using S over square root of n. And there's just like some added variability when we're doing that component there. So we just have to be really careful, and we'll talk about that again in a little bit later. But in general, if you want to find a 95% confidence interval, well, we know that about 95% of the data is 2 standard deviations away from the mean. So you can kind of create this like interval of confidence, if you will, about plus or minus 2 standard deviations away. And you're like, hey, I think the true mean is actually somewhere in here, like not just approximate, but like here is a range of values that I think the true mean is in. So here are the steps we'll use to calculate this confidence interval. First, you'll find your sample mean or sample proportion for the data set. If we know the population standard deviation, that is the best, but we'll talk later about what happens when we don't. In that case, you will find the z-score that corresponds to the confidence level that you want. So we might be 95%, we might be 90%, so you need to go find whatever your confidence level, let's do confidence. Whatever that confidence level is, that proportion, you need to go find your z-scores that correspond with that confidence level. And then you're going to calculate what we call the error bound. It is also called the margin of error. And that is this distance here. So based on that z-score, what is this distance? And then you are going to add and subtract that margin of error, or that error bounds for the mean, in order to find your confidence interval. Now, one thing that's really important is your z-score for your confidence level is going to be alpha over 2, where alpha is what's left over outside of your interval. So if I want to find a 95% confidence interval, then my alpha is 5% or 0.05. But that has to get shared, right? Because this is a middle piece. So my alpha over 2 means that each side has to share 0.025%. If I was doing a 98% confidence interval, alpha is 0.02, then each side of that would be 0.01. Right here is what we're going to use for our error bound or our margin of error. You are going to take the z-score associated with that alpha over 2 and multiply by your standard deviations. Just you want to know basically, based on the number line, how far is this piece right here? That's your margin of error. And again, we add and subtract in order to find that. Here is what we're going to say for our sentence stem. So we estimate with blank % confidence that the true population mean, and give it some context, is between these two things. And you can see we kind of made that diagram already in the notes, but this is the same diagram right here.